Okay, so for those of you who is pretty observant, you can see that yeah, I created like two modes for this little mini demonstration. One is a snap to tick, okay. The other is smooth, okay. And if you click and drag, you can see that ooh, I nearly moved pretty smoothly, right? So what is smooth? Is it really smooth? This is another new concept that I want you, and to be honest, it's a really, really important mathematical concept I want you to keep in your mind. There is like no definitive smoothness. Even though I also work as a programmer, I build this model. It's become really, really hard to me to say, well, I create the perfect smoothness. I sort of just say, hey, just make a really, really tiny little bit changes, and then you can't see like the difference. But in fact, it's just tiny little bits of snap, a snap, a snap. But you know what? Let's not just derail ourselves. I want you to use this to understand another concept called decimals. Okay, so what the heck is decimal? So basically, it's something like this. So you got like say 3, right? Oh, this is like 2.97. Okay, let's just use this. So for example, this is 2. This is 3. Okay. So that's the kind of like the number that we everyday use. But what about this in between? What about I just get inside in between, just at the very, very center of between this like 2 and 3? Okay, we can use decimal to represent that. And you know what? Right now, this is like a 2.97. You can't even see the difference here. It's pretty close to 3. Okay, so basically the decimal is like the small ticks. Okay, if if you change my sorry about that, if you change the whole mode to smooth mode, and you can see that the number is not, if previously like snap is not like connected, but if you change to smooth mode, you can sort of see that we got a lot of a small tick connect these two numbers. And each of the small tick, we can use like, oh, we got like a 2 decimal to represent that. Okay, so basically we cut that into many small ticks, small snap. And then you can use that specific even smaller number to represent the number in between. Okay, so that's kind of like the explanation of a decimal. But here's the thing: you can have a lot of decimal. You can, if you look at this, we can 3 and 4. You can like divide infinitely, divide countless decimal, right? And you know what? I can't possibly even draw that in the canvas here. Okay, so you can see that, oh, nearly I'm not changing, but the number is actually changing because I divided into very slight decimal. But sometimes the like, for example, 3 or 4 digit decimal, it doesn't have any meanings in real life. So mathematically, we can have a lot of decimal, but to be honest, most of the time we just use like 2 or 3 decimal. And in finance, maybe 4. Okay, in I don't know, physics and simulation, maybe like 6, 8 decimal. But in everyday life, you know what? I think 2 decimal is a kind of like the most detailed decimal that we go.